Hey everybody, today we are looking at 9.1, which is reflections, and we are starting our chapter on transformations. So the first thing that we need to know is, what is a transformation? A transformation is any time we change the position, size, or shape of a figure. When we look at our first figure, whatever it is that we're changing, that is our pre-image. Once we have transformed or changed our picture, that is called the image. So if we come over here and we look at this figure here, we've got triangle ABC. It has been moved over here to our triangle A prime, B prime, C prime. Notice this little prime notation right here. A lot of times we will use this to notate that this is the image. So this is our pre-image. This one comes first. Then this is our image. So this one is second. This is the one that has been moved. We say that this has been mapped onto this. And the way that we can write that is using the arrow. So we would read this as triangle ABC is mapped onto triangle A prime, B prime, C prime. And we use that arrow notation for the mapping. Okay, the next thing that we're going to look at is what it means to say an isometry. An isometry is any transformation that maintains the same size and the same shape. So if we look at these two triangles here, they have not changed size nor shape, so this is an isometry. Another word for isometry is rigid motions. You will hear me say both, so be prepared for that. When we're going to look at multiple types of transformations, today specifically, we are looking at reflections. If we think about this in terms of middle school vocabulary, it's a flip. We are flipping this figure over this line, okay? This line here is called our line of reflection. The way that a reflection works is that the distance from a point to the line of reflection and the line of reflection to its image is congruent. It is also going to be perpendicular to that line of reflection. So if we look at the length right here, this line from C to C prime, okay, line L is going to bisect it, mean cutting it in half, as well as be perpendicular. Okay, so that means that L is what we call the perpendicular bisector of the segment C to C prime. And that would be true for each of these points. If I drew the segment between B and B prime, L would be the perpendicular bisector of that line. Okay, so these are the same size, they are the same shape, they are just mirror images of one another. So let's take a look at example 1. We want to know whether or not each one appears to be a reflection, and why. So if we look at this one, it kind of looks like a C, and then this one looks backwards. So if I draw in a little line right here, that's pretty much our line of reflection. It is a mirror image. So yes, because the red figure is flipped. And we're only going to use the word flipped in this type of scenario when we're doing very basic things, because it's very basic vocabulary. I want you to use the word reflect. Okay, if we look at this one, it's kind of like an upside down F or a T. Notice that this is not flipped. It's just kind of slid over. This is actually a translation, which we will talk about tomorrow. So this one is going to be no, it is not flipped. Okay, if you have any questions on that or any of the vocabulary, please write that down on your note-taking guides now. Okay, so example 2, we want to draw the reflection of the quadrilateral across the line. Now, please know that I'm really asking you to sketch it, because we are not doing formal constructions with this. We will do those later. So right now we're just eyeballing and doing the absolute best we can. So here is what we're going to do. I am going to pick a point, and getting my tools set up here. Okay, so I'm going to start with this closest one. I want to draw a line that's perpendicular to this black line of reflection. And I want to try to draw it so this length is about the same as that length. So I'm going to put a point here. And I'm going to do that for each and every point of this quadrilateral. So from this next point, I'm going to draw a line with what I think is perpendicular. And again, try and draw it so that it is about the same distance from the line. So here to here. Okay? And then I'm going to draw a point right here. Continue doing that for the next ones. That's pretty close. So again, we want to try to make these so that we have right angles with this line of reflection. Again, we're trying to make the line of reflection a perpendicular bisector. That is what it means to make, that's how we make the reflection. All right, and we do this last point over here. And again, we're trying to make these the same distance. All right, and then from there, all we have to do is connect our points that we drew. And it's not going to be perfect, but it should be close, okay? So if you have questions on that, please write that down now. Okay, when we are reflecting in the coordinate plane, we have several rules for reflection. It will be very helpful if you can memorize these. Actually, you're going to have to memorize these. You're going to have to know what these are because there are going to be times I'm going to ask you for the rule. So if I have a point XY, okay, so any point, like let's take an example of a point. I'm going to shift that over here. If I look at 3, 7, if I reflect it over the x-axis, okay, my x is going to stay the exact same, 3, and my y is going to go negative, so -7. Okay, my reflection across the x-axis, if I did the same point, this 3, 7, okay, if I reflect it across the y-axis, my x becomes negative, so it would be -3, 7. Now, if I reflect across the line y equals x, and I still take that 3, 7, all I do is I switch my coordinates to be 7, 3. And please realize that the line y equals x is this one right here. Okay, this is the line y equals x. All right, so again, please, you want to make sure that you do know these rules. And if you have any questions on that, go ahead and write that down now. All right, so let's take a look here at an example of one that we are doing in the coordinate plane. We have a logo for a bank, and we're given the left half of the logo. We want to create the right half of the logo by reflecting it across the y-axis. So if we jump back here for just a second, I'm reflecting across the y. So my reflection rule is -x, y. So all I'm doing is I'm changing the sign of my x value. I leave y alone. So let's take a look. I have the point 0, 4, which is right here. Okay, if I change 0 to a negative, it's still 0. So my reflection stays in the exact same place. Okay, then we look at the point -3, 2, which is right here. All right, then I change the sign for my x value. So instead of -3, it becomes a +3. So it's +3, 2. So notice the distance that I go up from the x-axis does not change. It's just the distance from the y that is different. All right, so then we look at our next one. We have -2, 0, which is this one right here. So if we look at just negating our x value, it becomes 2, 0. So again, I'm going the same distance from the y-axis, and I'm going in a perpendicular fashion. So this is 1, 2 from the y-axis. This is going to be 1, 2 from the y-axis. That's going to be true over any line of reflection. Okay, so let's take a look at this point. This is -3, -3. So that's our next point, -3, -3. And again, all I'm going to do is negate that x value. So I'm going to go 3, -3. And that will be right here. And then the last point that we have is 0, -2. That's this one right here. So again, when we negate that 0, it just stays a 0. So this point doesn't move. It's the same. So then all we do from here is we connect our dots, and they should be mirror images of each other. So again, any questions you have on that, go ahead and write it down now. Let's take a look here. We want to reflect the point 2, 3 over the line y equals x. So the line y equals x goes through the origin and it has a slope of 1. So that's going to be this line right here. Okay, so remember that we have a rule for reflecting over this. Our point xy just switches to become yx. Okay, but also if you don't remember the rule, look and see. We go perpendicular to the line like half a box. We want to go perpendicular the same amount the other side right here. So our point that is reflected, our image, is the point 3, 2. All right, I also want to come over here and reflect the same point over the line y equals -1. Okay, so not always you're not always going to have a reflection rule for whatever it is you're trying to do. So we need to think about the line y equals -1. Well, because we don't have an x, we know it's either going to be a vertical line or a horizontal line. Okay, so every point on this line, the y value is -1. So that means my x value could be -300, -1, -2, -1, okay, 7, -1. But all of these y values are -1. So this is the line that we are reflecting over. So when you are reflecting over a line that you do not have a rule for, so like this one here, it's not the x-axis, the y-axis, or the line y equals x. All you're going to do is you are going to count and see how far you are from that line perpendicularly. So since this is a horizontal line, we are going to count straight down. So we go 1, 2, 3, 4. Okay, we are 4 units from this line. That means I'm going to go 1, 2, 3, 4 units down from the other line. So this point is the point 2, -1, 2, 3, 4, 5. Okay, so if you have any questions on that, just make a little note on this paper and bring it in, and we will continue going over these in class tomorrow. So I will see you guys tomorrow. Have a great day.